Okay, so now just like we had the times where a function cannot be continuous, we have the same thing with differentiability. So how can a function fail to be differentiable? Oops, sorry about that. Okay. Now we saw just on the previous example, whenever you have almost a drastic change in direction, it's not differentiable at that point. Okay, so we saw with f of x equals absolute value of x, that there is no tangent line at a point with a corner or changing or abrupt change in direction. Okay, so always put that to the, you say throwing a ball in the air. Remember, if you throw a ball in the air, it's going to go up and up and up, so you have a rate of change. At some point, it's going to hit the very top it's going to go, and then it's going to start to go down. If you had a ball and you had it in like a sharp corner, if you throw it up and then it immediately shot back down, then you don't have a rate of change at that point. It's just an immediate change of direction. So that's why you can't have one at a sharp turn. Okay, so for example, if you have that is your f of x, or even if you had, let's say here, and let's say from there it goes up. Anywhere you have that sharp change in direction, it's not differentiable at that point. Okay, so its second time it's not differentiable. Here's, we're going to go over what they call proof by contraposition. Okay, and that states that if some event A is true, then some event B is true. Okay, so they say that's exactly equivalent to, is equivalent to, if B is not true, then A is not true. Okay, so applying that to our theorem that we just went over, that just means that the theorem that says if some function is differentiable, then it is continuous. That is equivalent to if the function is not continuous, then it's not differentiable. Uh-oh. So that's the second condition when it's not differentiable, if it's not continuous. Okay. And third is if you have a vertical tangent. Uh-oh, not differentiable. So where, let's say your x equal a, it's on a vertical tangent. Uh-oh, why do I keep doing that? Okay. So let's say if our graph looked something like this. Let's say this is your x and your y axis. Okay, so you have a tangent line here. You have one here. You have one everywhere until you get to a point there. Then your tangent line is vertical. Now at that point, when you have that vertical tangent line, that's when it's not differentiable. Because remember, when you have a vertical slope, it's basically not even a function because it fails the vertical line test. So if you have that point and you have a vertical tangent at that point, then it would be differentiable. Okay. So any questions on that one? All right. Now, nothing we go over today will be on the test, just so you don't have to worry about that. All right. Okay, so most of the questions, as far as these sections go, will be in the form of graphs. So they'll give you a graph and they'll ask you various questions on it. All right, so we'll go through kind of a few examples. Okay, I had to kind of shrink this a bit to get all of them on here. But they want to know which of the functions show that it's differentiable at x equals 3. Okay, so what about this one? Nope. Yep, vertical. Okay. What about the second one? Yep, the second one is. Okay, so what about the third one? Nope, because you have that corner. And what about the fourth one? Nope, not continuous. Okay, so basically we have the one where it does work and all three of the conditions to where it wouldn't be differentiable. Okay, so any questions on that one? All right. And all of these will be scanned in the notes. Let me see, make sure I got the one. Okay, so why is this not differentiable? Let's zoom out a little bit. It's not zooming out. Is it out? This is out as far as you can go. Okay, why is that not differentiable?
Has a corner.
Yep, has a corner. All right, so what about this one?
That would be not continuous.
Yep, not continuous. Yep, so you know the limit from this direction is not the same as the limit from that direction. So, all right, so with this one, it's basically a description of the rate of change. So the rate of change is just like for a derivative, is just the same as it is for linear. If you remember, when you have a slope like that, that's a positive slope. When you have a slope, just a straight horizontal line, remember that's a slope that equals 0. And if it goes down and to the right, it's a negative slope. Okay, so the same thing applies here. If you want the tangent line here, then you know that that line will kind of brush across that dot, where the only point it touches on that graph is at that point. Okay, so you know here that at A, since it's a negative slope, you know that f prime of A is negative. Okay, so if you have f prime of B, if you drew a line just touching at B, what would the slope be? Yep, 0. Because you have whenever you have that horizontal slope, it's going to be 0. You'll clean it up a little bit. Okay, and what about C? Yep, whenever it's on a positive interval, your slope is going to be positive. Okay, so you have your negative interval. Well, not really negatives, more like decreasing interval. And when it's positive, you're going to have your increasing interval. All right, so any questions on that one? All right. Oops. Okay, so here they just want to know which interval is f prime of x, negative. Okay, so when they say that when it's negative, they want to know what's the interval where it's decreasing, basically.
X greater than 0.
Yep, so from 0 all the way to infinity. Okay, so it's going to be an open interval for 0 because remember 0 is where your slope is actually equal to 0 in this case. So f prime of x is negative on the interval from 0 to infinity.
Regular parentheses exclude the two numbers or include?
Exclude.
Okay.
Yeah, so if I had to bracket, it would include 0. Okay, so any questions on this one? All right. So for this one, at A is f prime of x positive, negative, 0. Yep, positive, because it's part of an increasing interval. Okay. Any questions on that one? All right. Okay. Now on this one, where is f prime of x positive? Yeah.
Negative infinity to positive infinity?
Yep, negative infinity, positive infinity. Because it goes, it keeps going up. Then as it gets to 0, it doesn't go into a slope of just nothing. It just keeps going up. So it's positive on the interval, negative infinity to infinity. Okay. Now, if it went up, hit a certain point, went straight for a little bit, then went back up, then it would be from negative infinity to whatever point it started to go horizontal, all the way to the end of the horizontal line to positive infinity. So it would pick up in two places. Okay. Any questions on this one? All right. Okay. Okay, so which interval is, or which intervals would f prime of x be negative? Okay, so we see here that you have a negative slope from negative x equals negative infinity to about negative 1. So for about this interval, it's negative, and this interval, it's negative. Okay, so that's where your f prime of x would be negative. I mean, not negative, decreasing. Okay, so you have from negative 1 to infinity. I mean, negative infinity to negative 1. Sorry about that. And you have from 2 to infinity, because it's just going to keep going down and to the right. Okay. Okay. So you know both of those are where f of x is decreasing.
Wouldn't that be f prime of x is decreasing or f of x?
Nope, just your f of x is decreasing. Your f prime of x is just negative.
Okay.
Yeah. All right. Any other questions on that one? All right. Now with this one, they want you to estimate the value of the derivative at x equals negative 1. I mean, negative 2. Okay. So whenever they want you to estimate the value, I mean, basically they want you to find the slope. So with this one, you can do one of two things. You can do the slope is equal to y2 minus y1 over x2 minus x1, or you can do the one we've been using so far, f of x plus h minus f of x all over x plus h minus x, which turns out to just be h, but since we have 2 points, we're going to use the x plus h and h in the denominator. So here they gave us 0, 5, and negative 2, 1. Okay. So remember, if we start on our left, that's our x. That's our x, which means that's our y, or our f of x. Then as you go to the right, it means this is your x plus h, which would make that your f of x plus h. And then from there, you just plug it right in. Your f of x plus h minus f of x over your x plus h, which is 0, minus your x, which is negative 2. Okay. So you get 4 over 2, which is 2. Okay. So notice a positive 2 because your slope is positive at that point. Okay. So that's really all you have to do for that one. So you haven't, not really an estimated since you just calculated that the slope is equal to 2. All right. So any questions on that one? Okay. Okay. Now for this one, they didn't give you the number values. So they want you to figure out, really straighten that up a little bit, the same thing. They want you to estimate the tangent. Okay. So whenever they don't give you the number values, you basically just pick a corner and find your own number values. Okay. So what if we pick here? Okay. So that's 1, 2, 3, 4, 4, 0. And this point here, that's 6, negative 4. Okay. So remember, when you're going left to right, that will make this your x. And this your f of x, which will make 6 your x plus h. That's your f of x plus h. Okay. So even if you didn't pick those 2 points, you could have picked this point here and that point. It wouldn't matter which 2 points you pick. You get the same answer. All right, so we just plug it right on here. So you have f of x plus h minus f of x, x plus h minus x, which gives us negative 4 minus 0 over 6 minus 4. So that gives us negative 4 over 6 minus 4, which is 2, which is negative 2. Okay. Notice again, you have a negative slope, negative derivative. And it's right on the decreasing part of the function. All right. So any questions on this one? All right, so we'll do one more. Okay, so they want you to use that graph to sketch the f prime of x, so the derivative. Okay, now sketching the derivative, you want to look for 3 things: where your slope is equal to 0, where the slope is positive, and where the slope is negative. Okay, you want to find where f prime of x is equal to 0, f prime of x is positive, and where f prime of x is negative. Okay. Whenever they want you to grab, most of the time they'll have like 4 or 5 different f prime of x's and they ask you to pick one. Okay. So we know here that our slope is equal to 0 at those 2 points. So we know our f prime of x equals 0 at x equals negative 2 and x equals 3. Okay. So now we have to find where it's increasing or positive. Okay, so we know that it's positive on this interval. So from -2 to 3, you have a positive rate of change. So on the interval, -2 to 3. And again, we're not including -2 and 3 because that's where the slope is equal to 0. So it's not increasing or decreasing there. All right. Now we know that our slope is negative on the interval there and there. That's when you have your decreasing function. Okay. So we know it's negative on the interval -infinity to -2. And from 3 to positive infinity. Okay. So any questions on this so far? Sure.
Why would it be to infinity? Because on that graph you cross 0 twice, so couldn't you assume that's going to repeat that?
Not necessarily. We're just you're kind of assuming that since they didn't show you any more changes, that there are no more changes.
Okay.
So
that's
it's
the
saying,
assumption
yeah,
to make for
they're
it,
basically
then?
saying that we're showing you everything it's going to do. From that point on, it's just going to keep on going. So I know they don't exactly tell you that, but you kind of assume it. All right. Now this is where we're going to get the information to make our graph. Here's your x and here's your y. Should have made that a little longer that way, but let's say this is our -2 and this is our 3. And it's just a quick sketch, so of course it won't look perfect. Okay. So we know our f prime of x is equal to 0. So we're getting ready to graph our f prime of x. Which means if f prime of x is 0 at -2 and 3, then at -2, our f prime of x is going to be 0. And at 3, our f prime of x is going to be 0. Okay. So we see that f prime of x is positive from -2 to 3, which means on our f prime of x, it's going to be above the x-axis. Now it could look like that, it could have all sorts of wiggles, but we just know that it's going to be above the x-axis. Okay. Now we know from -infinity to -2, and from 3 to infinity, it's negative. So we have a negative slope. The value of that's going to be below the x-axis. So it's kind of going to look like negative x squared plus whatever value. So that's where it's going to look kind of like that, like a negative x squared plus 3 or something like that. So that would be the graph of your f prime of x. Of course, it would be a whole lot better looking on the computer, but that's the graph there. All right, so any questions on that one? All right, so that's pretty much what you would have for this lesson. All right, and that's all we're going to go for today because I don't want to give you too much more over that with the test coming up. So we'll stop there.